Welcome to this platform. So in this video, we continue revising 2024 ECZ Internal Science Paper 2, which is chemistry. So far, we've done section A and section B, and the videos are available on this platform. You might want to check them before you come to this one. So in this one, we are going to end by, or we are going to conclude by answering section C. So section C, you are given 3 questions of which you are required to choose 2 of your choice. So the instruction, answer any 2 questions from this section in the separate booklet provided. So unlike in section B where you answer from the same, from the question paper in the spaces provided, in this one you are going to use the separate booklet. Okay, so let us answer question 1, that is C1. So the first question is draw a label diagram to show the bonding in copper. Draw a label diagram to show the bonding in copper. So one thing you should know that copper is a metal, and therefore the kind of bonding that occurs is metallic bonding. So to present the diagram for metallic bonding, we are going to draw, let us say this is a copper metal. So the atoms of copper inside lose electrons, and of course the electrons become delocalized. So when they lose electrons, they become positively charged, and of course electrons are negatively charged, and they become delocalized, or they are freely moving. Okay, so we have the positive charge of copper, and of course the delocalized electrons. So it is these delocalized electrons that gives the characteristic feature of the metal, such as the ability to conduct electricity, because they are able to carry charge. So to present it is going to look like this. Okay, so this is the bonding in copper. We have the positive ions and of course the electrons that are delocalized. The forces of attraction between the positive ions or metallic ions and of course the delocalized electrons, that is what we call metallic bonding. Then explain why metals are malleable. Explain why metals are malleable. So metals are malleable. So because that is C, that is B, C1b. So the answer is because the atoms in metal, so because atoms in metal can slide past each other, okay, slide past each other when force is applied. When force is applied, and can easily be shaped or modeled without breaking. Okay, that is what makes metal malleable, due to the arrangement of atoms. Okay, when force is applied, they are sliding past each other without breaking. Okay, this makes the metal easily to be drawn into a sheet. So that is for B. Then for C, let me just remove this. Like I said, the space here is not enough. So I'll be raising the answers. So make sure that you write them. So copper corrodes slowly. That is for C. Copper corrodes slowly in damp air. One of the corrosion product has the formula, this one. So copper corrodes slowly in damp air. One of the corrosion product has the following formula. So as you can see the formula, calculate the percentage by mass of copper in the compound. Calculate the percentage by mass. So let me just use this same top part, calculating the percentage by mass of copper. So I'm going to say percentage by mass of copper equal to mass of copper divide mass of the whole compound. Okay, mass of copper divide the mass of the whole compound, multiply by 100. Okay, multiply by 100. So in this case, mass of copper, as you can see, copper, you have copper here and copper here. One copper is 64. So 64 times 2, we are going to have 128. Okay, then divide the whole compound here. You have copper, if we are to find for this one, you have copper, which is 64. So 64 plus carbon is 12 plus oxygen is 3. So 3 multiplies 16 plus we have another copper 64. Then plus you have oxygen and hydrogen, which is 16 plus 1. Then multiply by 2. So the whole of this one is going to give you 220. 220. Okay, the whole of this one is going to give us 220. So divide 220 here, multiply by 100, and this one should be able to get 58%. Okay, so please, that is how you find the percentage by mass of copper. So we have 2 of the copper, we've multiplied by 2, which gives us 128. That is 64 times 2, 128. Then of course the bottom part, if we were to find everything, is giving us 220. Okay, so we should be able to find 58. So make sure that as you go through, you recalculate the whole answer. Make sure that you counter check. Mistakes can be made. So the second question, we've answered this one, percentage, calculate the percentage by mass of copper. The second question of C, how would you show that this compound here, copper carbonate, copper hydroxide, contain carbonate ions? So in other words, how do you determine the presence of carbonate ion? So that is on quantitative analysis, that is testing for anions. So make sure that you check that information. So this question, I'll leave it to you. How do you test for the presence of carbonate ions? How do you do it? Okay, so answer this question. Let us now answer question D. So question 1D reads, state 2 environmental problems related to the mining of copper. So one of the environmental problems as a result of copper mining is air pollution. Okay, so during the extraction and processing of copper, there's dust that is produced. This pollutes the air. Okay, so air pollution can be as a result of processing of copper and also extraction. Then it causes water pollution. So the other challenge is water pollution. Water pollution. So for water pollution, this mining or activity of copper may produce some chemicals. Okay, so the processing of copper may result into some chemicals, and of course these are discharged in the water bodies, hence polluting the water and affecting aquatic life. Also contaminate the soil. So contaminate, another one we can look at, contaminate the soil. So it contaminates the soil because of the chemicals as well. Aside from that, it destroys the habitat of animals. So I've given about 4 environmental problems related to the mining of copper. Let us now answer C2. So we've answered C1 fully, and as you can see, the total marks is 10 marks. So total marks of this one is 10 marks. So we've answered it fully. Let us answer C2. So for C2, the question is coming from acid, base, and salt. So the first question, that is A, Roman numeral 1 or A1, explain the term weak acid. Explain the term weak acid. What is a weak acid? So a weak acid is an acid that ionizes partially in water. Okay, it's an acid that ionizes partially when dissolved in water. So you can say partially when dissolved in water. So that is what we call a weak acid. Weak acid is also known as organic acid. So most organic acids are weak acids. Okay, so you need to know some examples of weak acids. Okay. Then the second question of A, write the ionization equation for ethanoic acid. Write the ionization equation for ethanoic acid. So ethanoic acid is this. Okay, this is ethanoic acid. So it's in aqueous. To show ionization, since this is a weak acid, the ionization is reversible, resulting into the ion of ethanoic acid and of course the hydrogen ion. As you know, the main characteristic feature of an acid is the hydrogen ion. And of course, you need to know how to define an acid. Give examples or types of acid. We have weak and strong acids, or we can say organic and inorganic, or mineral acid. So you need to know examples on each. All right, so this is the ionization equation of ethanoic acid. So you can add the state of hydrogen ion and also the ethanoic ion as in aqueous state. All right, so B. So for question B, the melting point of ethanoic acid is 16 degrees Celsius and its boiling point is 118 degrees Celsius. The melting point of ethanoic acid is 16.7 degrees Celsius and its boiling point is 118 degrees Celsius. Deduce the physical state of ethanoic acid at 130. Explain your answer. So give the state of ethanoic acid at 130 degrees Celsius. Now, as you can see, the melting point is 16. Then the boiling point is 118. Now, the boiling point is the point at which the acid begins to boil. And when it begins to boil, there's a change of state from liquid to gas. So now look at the margin that is there from 18 to 30. From 118 to 30. There's a huge difference. And therefore, beyond the boiling point, the ethanoic acid will be in gas form. So here they're saying deduce the state of ethanoic acid at 130 degrees Celsius. So ethanoic acid will be in gas state. What is the reason? Because 130 degrees Celsius is beyond 130 degrees Celsius is beyond or above the boiling point. The boiling point of ethanoic acid is beyond the boiling point of ethanoic acid. The molecules, therefore, of ethanoic acid at that particular point have enough energy to break free from the surface tension of the liquid and turn into the vapor. So the reason why we are saying it will be in gas state, it is because at that particular point, the molecules of ethanoic acid will have enough energy to overcome the force of attraction between the molecules, and therefore will be able to escape. All right. So because at 130 degree is beyond, or 130 degrees Celsius is beyond the boiling point of ethanoic acid, and that point the molecules or the particles will have enough energy to overcome the force of attraction. So that is basically what you have to explain in terms of this question. And I guess you've picked something. Would you happen to have another way you can put this one in the simplified way? Make sure that you contribute. Just state the question number and of course be able to contribute. I'll pin your comment so that everyone will be able to see it. Otherwise, we can move to the next question. That is question C. So for question C, the equation of ethanoic acid with potassium carbonate is shown as follows. As you can see, the equation, which is here, all right? So ethanoic acid or acid generally, they react with carbonate, and what is produced is a salt, carbon dioxide, and water. Whether strong acid or weak acid, the general reaction is just the same. So as you can see here, ethanoic acid react with potassium carbonate, which is a metal carbonate. What is produced is potassium ethanoate, which is a salt, plus carbon dioxide plus water. So the question is, Elena added 6.36 gram of potassium carbonate to 250 cubic centimeter of 0.224 mole per decimeter cubic of ethanoic acid, or 0.224 molality of ethanoic acid. What is the question? The first question is that show by calculations that potassium carbonate is in excess. Show by calculation that potassium carbonate is in excess. That is the first question, which is that is C question. So now how do we show by calculation? So to start with, so this is the C question, please. So to start with, let us find the number of moles of the two. That is ethanoic acid, and also the number of moles of potassium carbonate, since we are looking at the one that was the excess agent. And of course, if there's excess, the other one is limiting. So now let us calculate the number of moles of the reactants first, that is of ethanoic acid and potassium carbonate. So with potassium carbonate, we have the given mass, and therefore the formula that you use to find the number of moles is given mass over molar mass. Okay, the given mass is 3.6. Is it 3? 6.36 gram. Then if you are to look at potassium carbonate, the relative formula mass of potassium carbonate, potassium is 39. So 39 multiplied by 2 plus 12, which is carbon, then plus 16 multiplied by 3, which is carbonate. So if you are to add everything here, what is it giving us? Okay, so if you are to multiply at the bottom here, 9 multiplied by 2 plus 2 plus 12 plus 16 multiplied by 3. So what are you able to find? Here, the answer, we should be able to find 0.05, since we are finding number of moles, so moles. So these are the number of moles of potassium carbonate. Be able to confirm at the bottom here and make sure that you know how it is done. Okay, make sure that you do the correct multiplication here. So this is the number of moles of potassium. So we can write here in advance, number of moles of potassium, potassium carbonate, 0.05 moles. Okay, then let us find the number of moles of ethanoic acid. Now, for us to find the number of moles of ethanoic acid, what we are going to do here, we are not going to use the given mass, because on ethanoic acid, what we are given is the volume and molality, or concentration. So we are going to use concentration multiplied by volume. The concentration is 0.224, okay, mole per decimeter. Then the volume that we have is 250. Now we need it in decimeter. So 1 decimeter of the volume is equals to 1,000 cubic centimeter. So cubic centimeter, and that cancels. This is just the same as 250 divide 1,000 in decimeter cubic, and this gives us 0.250. Okay, so the volume here is molality 0.224 multiplied by 0.250. If you multiply this, you should be able to get 0.056 moles. These are the number of moles of ethanoic acid. Now, when we are done with this, what we are going to do now, we are going to put up a ratio, since we want to show that indeed potassium carbonate is in excess. So we need to determine how many moles of ethanoic acid reacted with potassium. So look at this, we are going to have a ratio of ethanoic acid, and we need to make sure that this equation is balanced. So ethanoic acid and potassium carbonate. Okay, so 2 ethanoic acid, so 2 moles of ethanoic acid react with 1 mole of potassium carbonate. So in this case, it's going to be 2 moles react with 1 mole of potassium carbonate. What about 0.0? No, these, yeah, okay. These are number of moles of ethanoic acid. What about 0.056 moles of ethanoic acid? How much of potassium carbonate will react? So when you form a ratio, we cross multiply here. We are going to have 2 more x is equals to 1 multiplied by 0.56, okay, more. What we want is to find the value of x, so 2 moles divide 2 moles. So x therefore is going to give us, or the number of moles that react with ethanoic acid, number of moles of potassium carbonate that react with ethanoic acid, that react with 0.56 moles of ethanoic acid. So divide that, should be able to give us what is 0.056 divide 2. We should be able to find 0.028 moles. So these are the number of moles of potassium carbonate that reacted with 0.56 or 0.056 of ethanoic acid. Now, since the number of moles are these that reacted, therefore we are going to subtract from the number of moles of potassium carbonate that we found, which is 0.05. So 0.05 moles minus 0.028 moles, and here we should be able to find, what are we able to find if we subtract and see what you find? So 0.022 moles of potassium carbonate are in what? Are in excess. So these are the number of moles of potassium carbonate that remain unreacted, and we've shown by calculation that indeed potassium carbonate was in excess. The question was show by calculations that potassium carbonate is in excess. Okay, so the first thing, we started by finding number of moles of both potassium carbonate and also ethanoic acid. After finding the number of moles, we need to find the number of moles of potassium carbonate that reacted with the 0.056 moles of ethanoic acid, and we found to be 0.028. Now, if these are the number of moles that reacted, what about those that did not react from the actual one? Actual number of moles of potassium carbonate are 0.05 mole. So we subtract the number of moles that reacted, giving us 0.022 moles of potassium carbonate in excess. So shown by calculation. Okay, I guess there's no confusion up to this point. I know my work is somehow, but of course I'm trying to utilize the space that is here. What is important that you followed, okay, or I've opened your mind that you can answer these questions on your own. Make sure that you try them at your own time. What about the D question? Calcium carbonate, this is the D question. Calcium react with ethanoic acid to produce calcium ethanoate and hydrogen gas. Construct the balanced chemical equation for this reaction. Calcium react with ethanoic acid to produce calcium ethanoate and hydrogen gas. Construct the balanced chemical equation for this reaction. So now what is reacting here is a metal, calcium, and ethanoic acid, okay, which is an acid. So generally a reaction produces a salt and hydrogen gas. All right, so let us see. So ethanoic acid, written as this, then react with calcium, which is the solid, this is the aqueous. What is going to form in this case is calcium ethanoate. So calcium has a valence of 2, and of course the ion of acid, which is ethanoic acid, has a valence of 1. So it's going to be like this. Okay, it's going to be like this. Then of course a 2 and the calcium outside. okay, then plus hydrogen gas, which is the gas. This is aqueous. Okay, so this is how it is going to look. Now let us check if it's balanced. Carbon, how many are they? 1, 2, 1, 2, that are just 2. Then this side 1, okay, 2. Then oxygen 2. Oxygen this side we have 4. Then calcium 1, calcium 1, okay. Then carbon we have 4. We have 2 here, this and this 2, so we have 4. So which means we need to put a 2 in front here, so that carbon we have 2 and again 2, which gives us 4. Then of course hydrogen we have how many? This is 6, then 8, so we have 8. So this is 6, then we have 2, 8. Okay, so this equation is balanced, and make sure you check it out. Okay, so if you don't know how to write the balanced chemical equation, there's a video dedicated just learning on how to write the chemical equation. You might want to find it also on this platform. It's readily available. So make sure I check that one out before you check that one out before you come to this one. Okay, then let us answer the last question. Let us answer the last question, which is C3. The question is on organic chemistry. So terylene and nylon are 2 common examples of macromolecules. State the chemical name for terylene. State the chemical name for terylene. What is the chemical name for terylene? So the chemical name is called polyester. Okay, polyester. Then what about nylon? Nylon is called polyamide. Polyamide. Then for the second part, that is B. By what process are terylene and nylon formed from their monomers? So they are formed by the process called condensation, polymerization. Condensation, polymerization, like that. Then the other question, identify the types of linkage found between the monomers or the monomer units in 1 terylene. What type of linkage are found between monomer units in A terylene? So the monomer units found in terylene, the monomer units found in terylene is ester. Not monomer units, please. Linkage is ester linkage. So the type of linkage found between monomer units in terylene is ester linkage. Then nylon is called amide linkage. Amide linkage. All right, so the last 2 questions, that is D. Lipids and proteins are also examples of macromolecules. Lipids and proteins are also examples of macromolecules or natural polymers. So proteins, lipids, and carbohydrates, these are natural polymers. Okay, now what are the questions? Distinguish between terylene and lipids. So differentiate between terylene and lipids. So the difference between this is that terylene is a synthetic polymer. So we can say terylene is a synthetic polymer, whereas lipids are natural polymers. So that is one of the difference. Then of course you can put maybe the other one in terms of maybe their use. So terylene is used in textile, whereas lipids are used in they play crucial role in biological processes in living organisms, such as energy storage, and also they make the structure of a cell membrane. So let me just repeat that. So terylene is used in textiles, whereas lipids are used or play a crucial role in biological processes such as energy storage, and of course also forms the structure of the cell membrane. So that is another difference that you can give. Then compare protein and nylon. Compare proteins and nylon. So this one is a question that I'll leave up to you to answer this question, so that I see those that have watched the whole video. So at the end, I normally leave a question, and this is the question that I'm going to leave. That is compare proteins and of course nylons. Otherwise, we've come to the end of the presentation. And please, if you've enjoyed the video, do not forget to subscribe. Make sure that you invite others. And also, if you want to help in terms of tuitions, extra lessons, that is both physical and online, you can just get in touch on the number 0976 402563. So for physical lessons, we are found in Kabwata along 80th Street. That is near Kabwata Primary School. So if you stay in that area, do come through. And weekends, we offer free revisions. So get in touch. Otherwise, we can end here and see you in the next one.